So what is the big deal about this new AWS service Aurora DSQL anyways? Isn't it just another database service? Let's try to explore. But before we do that, let's try to refresh our understanding about a few database concepts and about a few cloud concepts. Let's look at some database concepts first. Distributed. It essentially means that the operations, your compute and storage of your database is not restricted to one server, but is distributed across multiple servers. And these servers can be in multiple regions as well. When I say region, I essentially mean geographical region from the perspective of a cloud infrastructure. Latency, the amount of time it takes for you to get a response from a database. Low latency means fast responses. So this is low latency. And high latency means slow responses. So this is high latency. Sharding. Just like the word suggests, when you break something, you get small shards or pieces. In an exact same way, sharding essentially means breaking your database into small pieces so that it's easier to manage. It is one way of improving the performance of a big database. Read replicas. It is a way in which you can create copies of your primary database and spread it across nodes or regions, and these copies only cater to read requests. You still do the writes from a central location, but you handle read across multiple locations. This is also one way of improving the performance of your database. Active multi-region writes. If you have your database spread across regions, active multi-region write essentially means that you can simultaneously update your database at two different locations. Consistency. When you update your database in one location, the process of it getting replicated or updated across the nodes of your database is called consistency. Now you have different types of consistency. Eventual consistency, which essentially means that the database will be updated eventually, but it might take a bit of time. Strong consistency essentially means the database is updated real time. If something is updated in one node, it takes very little time to replicate across the nodes. Optimistic consistency essentially will allow updates on multiple locations with the assumption that conflicts will be rare, and it will have a way to resolve conflict at the time of commits. On the contrary, pessimistic consistency works on the assumption that conflicts will be common. So essentially it uses locks in order to prevent conflicts. That means if a write operation is going on, no other process can write till the write operation has finished. Isolation. Isolation essentially ensures that transactions don't interfere with each other. And what level of visibility do parallel transactions have? To give an example, assume you have a process A which is updating some records in the database, and you have a process B which is also updating some records in the database and is using similar data which process A is updating. Now isolation essentially will define what level of access will process B have of in-process data that process A is updating. Now a low level of isolation would mean that process B will have access to quite a bit of data that process A is in the process of updating. And high level of isolation will mean that process B will not have any access to the data in process of getting updated, and it will be able to access that data only when the update has been finished. So that would mean essentially a high level of isolation. Now let's try to understand some cloud concepts. Distributed essentially means your workload, your compute, your storage is distributed across nodes and across locations. Multi-region essentially means your solution is spread across multiple geographical regions. And when I say regions, I mean regions from the perspective of cloud infrastructure. Serverless essentially means a service in which you are not bothered about the underlying infrastructure that is running your process or workload. To give you an example, if you have to run some program on a server, you essentially will provision a server. In case of AWS, it will be an EC2 instance, then you will install some applications, then you will run your code inside it, and you will have your service running in that server. In a serverless setup, you really don't have to bother about the server, and you just provide your code and your configuration to this service, and this service takes care of everything in the background, similar to what Lambda does, where you just provide the code, you provide the runtime and some configurations, and you run your application without even worrying about the server that it is running on. Now, serverless, you also pay for what you use. What that means is if you are running your service for 3 seconds, you pay for the services only for that 3 seconds. On the contrary, when you provision an EC2 instance, if your EC2 is running for the whole day and you use it only for say 3 seconds, you still end up paying for the entire day. Elastic. As the name suggests, elastic essentially means something which expands when there is pressure and contracts when there is no pressure. So in case of cloud infrastructure, elastic essentially means a service that expands or increases its capacity whenever there is an increase in load, and which shrinks in capacity whenever that load reduces. To give you an example, suppose you have a service which takes one node to service your regular amount of traffic. Now, suppose your traffic increases 10 times. An elastic service will automatically add 9 different nodes to serve that traffic. And once that traffic reduces, say it reduces to 5 times the normal traffic, it will shrink the number of nodes to 5 to serve your request as per your traffic. And if it reduces to regular traffic, it will come back to 1 node. So this essentially is an elastic service. Fully managed essentially means your cloud service provider is responsible for all the upkeep and maintenance of the infrastructure of the service, which essentially means provisioning, patching, backup, scaling, everything related to that service is taken care of by the cloud service provider, and you don't have to worry at all about it. On the contrary, self-managed means you are responsible for taking care of all these things: patching, backup, scaling, and maintenance of the server. It's your responsibility. Scaling essentially is the process of increasing the capacity of your infrastructure to accommodate your traffic or workload. You have horizontal scaling, which essentially means if you have one server which can serve your regular traffic and your traffic has increased 10 times, you are going to add 10 more servers. So this essentially is called horizontal scaling. Vertical scaling means you add more resources to the same server. So if your server has, say, some amount of compute or memory or storage, and your workload has increased substantially, you add more compute, more storage, and more memory onto that server itself. So that is called vertical scaling. Now that we have understood these cloud and database concepts, let's try to look at what this new Aurora DSQL service is. So Aurora DSQL is a multi-region, fully managed, distributed database which is elastic, infinitely scalable, with low latency, supports active multi-region writes, and is strongly or optimistically consistent across regions, and is serverless. So is it really a different technology? Not really. Distributed databases have been there for some time. Google has a similar service called Google Spanner. Microsoft has a similar service called Microsoft Cosmos DB. There are a couple of open source tools like CockroachDB and YugabyteDB, which provide distributed database solutions. They also have their own managed cloud services. So it is not a new technology. However, there are some aspects of the Aurora DSQL which are a bit different. Let's take a look at what's under the hood. What we understand is AWS runs multiple components of these databases as ephemeral microservices, which essentially allows it to scale independently and infinitely. And when I say multiple services, I mean the query processing system, the transaction system, and the storage system of these databases. Also, AWS uses Firecracker to run these microservices. Now, Firecracker, as you know, is a micro VM technology developed by AWS, which is also open source. It is the backbone of serverless services of AWS like Lambda and Fargate. Firecracker essentially enables you to run micro VMs on bare metal, and these VMs are super fast, super secure, and super scalable. Aurora DSQL supports Postgres, but at this point in time, it supports only a subset of features of Postgres. So this is what Aurora DSQL is all about, and this is the reason why it has created such a buzz in the tech community. Hope you liked it. See you in the next one.